The next thing I want to talk about is a topic that's called functional error handling. And I think I describe this best currently in my book, Learn Functional Programming the Fast Way. So I'm going to use the chapters in this book to demonstrate what this means. In lesson 16, I start off with a preview of what functional error handling means. And in short, what it means is that when you have errors or potential errors inside of a function, the Scala approach, and really the functional approach, is to use what I show here. That's error handling data types. And so what that means is that when a function can fail, you should return one of these types, this option type, the try type, or the either type. And if you've used Java or other programming languages, they have started to adopt this option, or I think in Java they call it optional, but it's a similar type. And what I'm doing in this book is I'm writing a word count function. So this is the word count function. It takes a file as input. And then because of reading a file can cause an error, like you can get a file not found error, or there can be a permission problem trying to read the file, you want to let the caller of your function know, hey, something went wrong here. And the Java way used to be, for many, many years, you would throw the file not found exception or a similar exception. But the way we do this in functional programming is you handle errors with types. And as I mentioned, in Scala, the three main types for functional error handling are option, try, and either. So that's what you do. You write this function, word count function, and it's going to return one of these types. And then inside these types over in this area is where the contents of the file is going to be contained. Or more accurately, I should say, if it succeeds, the contents of the file are going to be in here. And if not, I will show you what's going to happen in just a moment. And actually, that leads into this next discussion. So error handling types, I call them wrappers. I know some people don't like that, but I call them wrappers. And they contain one of two possibilities. So if the function succeeds, you'll be able to access the success value inside of any of these option, try, or either. And if the function failed, you can access its error value. And so you can think of that as a container, and the container is going to contain a success value or, and that's a very big or, it needs to be even bigger, or a failure value. So you think of it as a box, going to contain this or that. And as I note here, a great thing about this approach is that unlike exceptions, which kind of blow up your code, error handling data types don't short circuit your code. You just handle them just like you handle any other data type. And that's a very, very cool approach. It took me a while to get used to this. But you treat the error or the result as a value, and then you continue writing your code as algebra, as I note here. And I mentioned that there are the three error handling types, option, try, and either. And all I'm going to do in this lesson is focus on option. So please try to ignore this other stuff here. The important part is option is a parent type, and then it has two subtypes, some and none. And you can see those here in this fancy diagram that I drew. So option is the parent type. Sum is the success value. So this could have been called success, but it's called sum. So if, for example, my file reading function works, the contents of the file are going to be inside the sum. And if the file reading fails, such as a file not found exception or any other problem reading the file, you'll get a none from that word count function. So again, these two are subtypes of option. So if I scroll back up here, when I declare option right here, that actually means that the actual value you're going to get back from this function is either going to be a sum or a none. And now my classic way of demonstrating this problem and solution goes like this. You want to create a function, we'll call it makeInt. So I'm going to take a string as input, and I'm going to attempt to convert that to an integer. And in the old days, what I would do looks like this. So I would say try to do s.toInt, and this example is a little contrived, but it demonstrates the problem very well, I believe. So when you try this code right here to convert a string to an int, it can throw an exception. It can throw a number format exception. So then we handle that inside of a case statement with a match expression. So then I will say for any exception that you get, and if you want, I can make that a little bit easier. I can say for any exception, anything that's a number format exception, what I want to do here is just return 0. So what happens here is if you receive a string and you can convert it to an integer, the result comes out right here. if you get a string and then this throws an exception, what happens is that the function returns 0. So now what I can do with this function is I can copy that, and I could have just done this in the Scala REPL all along. So let's go ahead and fire up a REPL. I will paste that in. And let me show you both the good and bad part about this function. So if I call make int and I pass it a string which contains the number 1, we get that. And if I pass in a 0 as a string, we get that. And now you can see where things start to go wrong. I pass in a blank string and I get 0. I pass in the number 1 as a string and I get 0. And I could continue, but I think you see what the problem is. It works well in this example here, works fine here. And then once you start getting here, 0 doesn't make sense anymore, does it? Because this should actually fail. This is not a value that can be converted to an int. And if the algorithm was smarter, this one could be converted to the number 1, but it's not very smart. So it should not return 0. It should fail, just like this one failed. So that's a problem with this version of makeint. It's not handling failure properly, or it's not handling errors properly. So the way we handle this in Scala is we fix this function and we say that instead of returning an int, it returns an int, but it's wrapped inside of an option. Okay, so now that's going to be the same. And what we do here is we wrap this guy in a sum. And then instead of returning 0, we return none here. And now we can take this code and go back to the REPL. And if I didn't make any mistakes, I could just do a clear there, paste that in. So that's our new makeint function. And now I can go back and say makeint. There's that 1. And now you see it returns an option of type int. And the actual value is shown over here on the right side. So this is the way the REPL works, is it shows the type over here and it shows the value over here. So this is actually returning a 1, and that 1 is wrapped inside of a sum. And similarly, if I pass in a 0, we get a sum 0. And now when I pass in a blank string, we get a none, which is the correct answer. And if I do this, we get a none, and that's also the correct answer. And I should say this is the correct answer because this is as far as I'm going in the algorithm. And maybe a better example would be hi mom, and there you get a none. So now this is working correctly. Makeint isn't throwing any exceptions, and it's returning, as you see, it's returning 2 different types of values. One is the sum in that example, in this example, and then in all these other examples where the string cannot be converted to an int, I return a none. And there are quite a few different ways we can handle an option that we get back from a function like makeint. So let me just set a value here. So let me set s equal to, we'll start like that, 1. So currently s is that string 1. And the way you handle this, so you'd call makeint, and you pass it that string. One way to handle this is with a match expression. So you say I want to match it. And in the case where I get a sum of an integer, then let's just go ahead and print line. I'm trying to keep things easy here. So we will just print that integer out. And if I get a none, case of a none, what I want to do is just say print line, we'll just say no match. Trying to think of something clever to write, but that's good enough. Okay, and you can see that gives us a 1 in this case, and that's because the value s is a 1 right there. And now if we go backwards, and we go back to hi mom, we change s to hi mom, and we come back here to makeint and run this again. Now we get no match. And that's because hi mom is passed in right there as a string. It comes down to none, and then that prints no match right there. An interesting part of this solution is that if for some reason or another you were okay with getting that 0 before, you can also do this. You could say, I want to do, well, actually, I should assign this to a result. So I say result equals that. And then we could say get or else 0. And I know I just told you that these zeros are bad, but there are some situations where you might want to do that. So this could be hi mom, and that one will be a 0. So the 1 succeeds, so you get the 1, and then get or else means get the value if it succeeds, or else use this. So here, this one fails. So then it says, or else I'm going to give you a 0. And then sure enough, it gives you the 0. I actually use this very, very rarely, but it just came up in my mind. So I wanted to show that. This is a very common way to do this with a match expression. And you'll also use this inside of for loops and for expressions. So let me do another for expression here. And I'm going to say, I'm going to show you the type here. Well, actually, let's start without the type first. Let's do val res equal for expression. So I want to do a in make int, give that one a 1, b. And now, so I'm going to call make int multiple times here. That's what I'm doing. And the first time through, I'm going to give it all good values. And then if all those succeed, I'm going to yield a plus b plus c. And all those do succeed because I hardwired the values in right there, 1, 2, and 3. So then the result, my variable res right here, has the type option of int, and its value is the sum of 6. So what happens here is make int is returning an option each time it comes through here. And because these are all successful values that can be converted to integers, each of these return a sum value. And the way you deal with this is down here, you don't worry about whether it's a sum or a none. You just assume success when you're writing the code here. Maybe that's a good way to say this. You assume that you're getting a sum out of each one of these, and you assume success. So whatever your algorithm is here, you just assume that these are all ints. So you treat them as the integer data type right here. And then when everything is done, when the for expression is done, this res variable will end up containing the result of this expression wrapped inside of a sum as shown right there. And a couple more notes about this before I finish. One thing is sometimes it can help you or other people to see that this is going to be an option of int. So you can declare the type right there like that. And that doesn't change anything, but for readers of your code, they can say, oh, okay, res right here is clearly going to be an option of int right there. And the reason I didn't show that is a lot of times, most people use IDEs during the development process, so they can see pretty easily within the IDE that it's going to be an option of int. The other thing I want to show, and I'll go back here, is that when this blows up, what happens is res is now a none. And that happens because this guy is short-circuited right here. So make int throws a none, and then what happens inside this for expression is it says, whoa, I got a none right here. Don't even bother doing anything else right here. I got a none. So let's stop the presses, assign none, the value none, to the variable res, and that's what you see here. But a cool thing about this is that when everything succeeds, so you get these 3 values right here, these 3 values converted successfully. So then res becomes a sum of 6. And you can see there are no exceptions thrown. Res just has this value. And when things fail, like in this case here with the hi mom, the loop still succeeds, no exceptions are thrown. And now res just has a value of none as shown right here. And then what you do in your next lines of code is you deal with that however you want to. So now this right here could say res, match, and then you would deal with the sum case and you would deal with the none case right there. And to wrap this up, now that you've seen how option, sum, and none work, I can tell you that try, success, and failure, and either right and left are very similar to this approach right here. And what I mean by that is you can look at the class hierarchies. So I just showed option with sum and none. So option is a parent type, sum and none are its children. Try is a parent type, and success and failure are its children. And on the next page, we have either is the parent type, and then left and right are the 2 children of it. And the big difference with these guys is, as you saw in the example, none doesn't have any information associated with it. You just get a none value back from it. And as a programmer, that means that when you see a none, that means that the algorithm failed. And the difference with try, success is basically equivalent to sum. It will contain the success value, and failure contains the exception. So your code, your function, your make int function will look a little bit different, but then failure will contain the exception that's thrown. And a good thing about that is if you're trying to read a file or access a web service or a database, you get good information back here. You get the actual exception that happened. And so when I'm dealing with external effects like that, file reading, databases, web services, that sort of thing, I will tend to use try because I like to get that exception information back. Or you can use either. And so what happens with either is the success information is contained inside the right. So that's just like a sum or a success. And then the left guy over here can be anything you want it to be. So it could contain the exception, it could contain a string, it could contain a value from an enumeration, or whatever you want, whatever makes sense to return. So it turns out that either is the most flexible of all three. And then the last thing I'll say is that as we go further into this course and as we get into the advanced Scala course, we'll see these other types more. So we'll see all three of these actually. So we'll see option and we'll see try and we'll see either in the advanced Scala course.